Hello all. Let us see the one example of eigenvalues and eigenvectors. First example is find the eigenvalues and eigenvectors of the matrix A equal to minus 2, 2, minus 3, 2, 1, 6, minus 1, minus 2, 0. So this is the given matrix. The step 1 is find the characteristic equation. The characteristic equation of the matrix A is lambda in general form lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. It is the general form of to finding the characteristic equation. Mm, this is also another method we have to find the characteristic equation. Here, the S1 is the sum of main diagonal elements. S2 is the sum of minors of the main diagonal elements. So, we have calculate S1 sum of main diagonal elements. From this matrix, the sum of main diagonal elements, these are the main diagonal elements. This sum is minus 1, sum of minus of main diagonal elements. So we have find out the minor of main diagonal elements. So main diagonal elements are minus 2, 1, 0. The minor of main diagonal element, which means that minor of first element is 2. So minor of 2, we can calculate minor of minus 2 by hiding first row and first column. Then the determinant of the remaining elements, that is the minor of minus 2 plus minor of 1, minor of 1, which means second row second column, by hiding second row and second column. So the determinant of remaining values is the minor of minus 1. Then minor of 0, 0 is the null value, so the determinant value becomes 0. So minor of 0, which means by hiding third row, and third column. Then remaining determinant of remaining elements. The total sum is minus 21. So S3 is the determinant of A. So the determinant of A is the value obtained from the given matrix. Determinant of given matrix, the value is 45. So substitute S1, S2, S3 values in characteristic equation, which means the characteristic equation becomes lambda cube plus lambda squared minus 21 lambda minus 45 equal to 0. Then step 2 is to find the eigenvalues. From this characteristic equation, we have to find the roots of the given equation, this equation. So the roots of this equation are minus 3, minus 3, comma 5. It is a repeated eigenvalue. So we find eigenvector. Next we have to find the eigenvector a minus lambda I into x. A minus lambda I into x. Substituting A given matrix, I is the identity matrix, x is the column vector x1, x2, x3. So I lambda into I, that is lambda 0, 0, 0 lambda 0, 0, 0 lambda. We have multiply and solve this matrix, we get 3 equation. When lambda equal to, substituting when lambda equal to minus 3, we get 3 equation. From equation 1 and 2, from 2 divided by 2. So from equation 2 overall divides by 2, we get x1 plus 2 x2 minus x3 3x3 equal to 0. From equation 1 and 2 we get the eigenvector 1. So by solving above two equation we get the eigenvector 1. In case 2 lambda equal to minus 3, so we get eigenvector 2. In case 3, when lambda equal to 5, we get the x3 value. Suppose let us considering these two equation, how to find x1. So the value of x1 becomes by hiding these two column, that is x1 column. Then we have to find determinant of other values, that is 2 minus 2 minus 3 minus 2 minus 3. Next, finding x value of x2, then hiding x2 values and determinant of the other values, other coefficients. So we get x1 x2 x3, which is the eigenvector 3. So let us see one example assignments. Transpose of a column matrix is, any guess? Transpose of a column matrix. What is column matrix? We can change row into column or column into row. That is the transpose of the given matrix. So transpose of a column matrix. Column matrix consists only one column. So transpose of this, so it is the row matrix. The correct answer is D. Next, if determinant of A equal to 0, then A is determinant of A, which is equal to 0. Therefore, A is singular matrix. Let us see further another example in next video. Thank you.